Here's an example where we will calculate a payment required to pay off a loan. And in this case, actually, we're going to do this 3 times because really what we're asked to do is to compare 3 different loan offers and then determine which one is best. And by best, we're going to evaluate that as in, is it affordable? The monthly payment, that is. And in particular here, this person wants a monthly payment of $225 or less. And then that, if it's $225 or less for the payment, then they would deem that loan affordable. So as you read, that bank is offering 3 different loans, really. So we're going to do this 3 times using this formula that I've already identified here from page 245 in our text. This is the loan payment formula. All right, so I've rewritten the formula down here towards the bottom of the screen on purpose because I want to show at least one time how these values from loan 1 in particular get placed or substituted into this formula. Okay, so let's start with PMT. That's the payment amount. That's what we don't know, so we're going to leave it just like it is. It's our unknown. But P, we do have a value for in loan 1, and we're told that that is $12,000. So I can erase that, and I'm going to replace it with $12,000, like this. For APR, we're told that's 6%, but we know that we don't write the percentage, we write the decimal form. So for APR, let's replace that with 0.06. N was implied here because we do know that we're making monthly payments. So by monthly, we are compounding 12 times per year. So N, number of payment periods per year, will be 12. And some of these pieces are just part of the formula, like the ones, the pluses and minuses and things like that. So I'm not going to change anything there. I will also replace this APR with the value we just stated, and I will replace N with the value we just stated. That was 12. And then again over here, oops, N is 12. That is a negative sign in front. And there's an implied multiplication sign between the N and the Y. So placing that there. And Y was the number of years. So for loan 1, it was going to be a 4-year loan. Now with that, we have correctly substituted all the information for loan 1 into the formula. Now we have some choices. We could go through this using order of operations and take our time step by step, or we can speed it up just a little bit with some technology. And in particular, I'm going to show the TI-84 calculator. So either pause this video or take a screenshot of the formula with the substitutions that we've made, because what we're going to do now is place that with those values into our home screen on the TI-84. So first of all, this is like a complex fraction or fractions within fractions. There's a lot of operations going on. And I'm going to start by bringing up the fraction. That was alpha y equals. And in the numerator, I have 12,000 times. And in parentheses, I have another fraction. So another alpha y equals, enter, 0.06. I can arrow down to the denominator. I can arrow out. And now I'm finished with the numerator of this larger fraction. Underneath, where you see square brackets, the calculator does not like square brackets in the same way that we write them, so I just have to use parentheses. It's okay, still a grouping symbol. And that's 1 minus, another parentheses, 1 plus, another fraction over 12, come out of that fraction, and then an exponent. And in that parentheses, we have negative 12 times 4. And then I can come out of that exponent by pressing the right arrow, close the parentheses in the denominator, and then just press enter. And this immediately gives me the payment method It keeps me from having to do a lot of scratch work and remembering steps, especially in such a complex formula like this. I would highly advise to use the technology when you can use the technology. So again, that was for loan 1, and the payment was $281.82. And notice that's above what he says he can afford. I say he, she, whoever says that they can afford, this person. So they can only afford $225, and that means the first loan is out of the question. It's not affordable. So really what we need to do now is just the same process 2 more times. So I'm going to speed it up just a little bit here by not showing every small detail, but just jumping directly to the calculator. I can save a step in the calculator. If I scroll up and highlight the expression and then press enter, it will like copy and paste. And then I can just adjust as I need the values as they have changed for loan 2. So like for instance, one of the values that has changed in loan 2, if I use my arrows to scroll to get to it, is the APR. It's now 0.065. So I'll go through and make those changes. And one more value that changed was the number of years. Instead of 4 years, it's now 5 years. And everything else was the same. And here is the payment, $234.79. Again, too much for our person here who's trying to get this loan. So let's do that one more time. So again, I just copied and pasted the expression, updated the values for loan 3, and I see that loan 3's payment is $204.59, $204.59, and that is doable for this person because it's less than $225 per month. Again, just coming back to our question and making sure that we're answering the question that's asked. I see that the payments for loan 1 and 2 are more than what's affordable. And affordable is defined here as $225 or less. The payment for loan 3 is less than $225, so this is the loan that we would like to accept. And if you think about it, it kind of makes sense that even though the interest rate's a little bit higher here, the number of years that we're stretching this loan out for are longer than the other 2. But as we've seen in other problems, just as a general warning, that means that we will be paying more interest over the long period of this loan. So, but that's a compromise that sometimes we have to make. A lower monthly payment, but in the long run, we may be paying more interest.